example 6.1 now. So if you push your physics book 1.5 meters along a horizontal tabletop with a horizontal push of 2.4 newtons, while the opposing force of friction is 0.6 newtons, how much work does each of the following forces do on the book? Your 2.4 newton push, the frictional force, the normal force, gravity, and what is the net work? So I have these four forces, and I want to know what is the work done by each force, and then what's the total work, the net work. All right, so I'll remind myself that work is the force dot the displacement. Okay, so I need arrows on all of my forces and on my displacement so I have their directions. Another thing to remember is that when doing a dot product, if the two vectors are perpendicular, the dot product is 0. So in our case, if the force is ever perpendicular with the displacement, 0 work is done. So let's get started. So to find the work done by the applied force, which we call an input work because it's typically adding energy, we're going to do our 2.4 newtons, and it's in my positive direction. So maybe I'll put even a little positive there, times positive 1.5. And so my work in is going to be 3.6 joules. So that is my work in. Now the work done by friction, okay, so the work done by friction. So I notice that it's pointing to the left, so it's going to be a negative 0.6 newtons times my positive 1.5. And so the work done by friction is a negative 0.9 joules. Now when I get to normal force, all right, so C, the work done by the normal force is going to be 0 joules. Now I want you to get in a habit now. Whenever you're going to write 0 joules right like this, don't just leave it like that. Tell me why. And so you're going to say something like because. So if you use 3 dots like this, it means because. So the work done by the normal force is 0 joules because the normal force is perpendicular to the displacement. Whenever I see that 0 joules, I want to see that there, or that because statement. Same thing for work done by gravity. Again, 0 joules because the force of gravity, mg, is perpendicular to the displacement. If you want to write this as capital F sub g for force of gravity, you're welcome to. All right. So what do these mean? So I have a positive work, I have a negative work, and I have 0 work. Whenever you have a positive work, it's telling you you're adding kinetic energy to that object. Whenever you have a negative work, it means you're removing kinetic energy. So this one here is trying to increase the kinetic energy of that textbook. This one here is trying to decrease the kinetic energy of that textbook. These are not changing the kinetic energy of the textbook in any way. Now to find the work net, all I need to do is add all of these up. And so I have my positive 3.6 plus my negative 0.9. And so my work net is an overall positive 2.7 joules. Now because it's positive, that means the net effect is to increase the kinetic energy. And if I'm increasing the kinetic energy in a net sense, that means that I'm speeding up. Okay. So there's your example.